All right, how's everyone doing? Patriots lost.
We're still on that high.
Yeah. All right, cool. So, so PA2 is graded. PA2 was really good. So people did a really nice job on that. Good things I saw. So good commenting. In most cases, people are putting in reasonable comments right throughout the code. That's really important. It's going to help you not only in this course, but other courses, jobs, situation, all these other things. It's going to be really good to be able to document your code. Even if you decide down the road, maybe I don't need comments, you know, as much as I did in 222. Being able to do that when you're asked to is an important skill. So I was really happy to see that. By and large, the code worked exactly the way it was supposed to. So that was really exciting to see. Memory leaks. The majority of people did not have any memory leaks, which was great. Of the cases where I saw memory leaks, almost all of it was a single node, which probably means it's a Sentinel not being released, or there's one spot where you're doing a malloc that you didn't need to do, and you left it dangling. But I'm not worried about that, right? So people were cleaning up after deletes and usually doing some semblance of deleting the entire list at the end of execution. So that was really good. Other things. So a few cases where the output was in a different format from what I wanted. Right, I really wanted a list of numbers separated by spaces on one line. And some people printed number per line, some people printed extra information, and so on. I didn't take off for it on PA2, I will on PA3. Okay, PA3, it's gonna have to be the way the assignment says, so all the output on one line separated by spaces, top of the stack on the left side, and so on and so forth. So be careful with the output format. I wanna talk about makefiles. Okay, so everybody included a makefile, and the makefiles did the right thing. They made the executable. That's the primary goal, right? I took your code, pulled it into an empty directory. I said make, gave me an executable, and I went ahead and started testing that. That was great. Okay, so I'm very happy with that. I want to talk about nuances of makefiles, though. There's some different things that we can do in makefiles to cause them to be more efficient. So let me show you an example of a makefile that I got. So this builds an executable PA2, and I got permission from the student to use his code for demonstration. So PA2 is the executable, and it depends on these .c files, and if those .c files are present and up to date, then it executes the second line, which is this GCC command, right, which compiles everything and links it together and gives you your executable named PA2. That's great, okay? They also had all of this other stuff in here, but none of this stuff ever actually affects anything. So the way a makefile is set up, remember it's this pairing of statements. So we have pairs of lines. The first line is a target, something we want to make, followed by a colon, followed by a list of dependencies. Things that need to be present and up to date in order to make this target. And this is followed by a line, begins with a tab and a recipe. The instructions for how to make that target once those dependencies are satisfied. And it's just pairs of these lines again and again and again. Okay, that's the basic structure of a makefile. So what are we saying here? We have a target called PA2.0. And in order to make that, we need to have up-to-date versions of PA2.c and Node2.h. And if we have those two dependencies, then here's the recipe for creating PA2.0. Okay? That's perfect. It's exactly what you want. But there's nothing in the dependencies or the recipe for PA2 that requires PA2.0. So if you just say make, it always tries to make the first target. So if I just say make, it'll try to make PA2. And all it cares about are these .c files. It doesn't need a .o, so it's never going to require that this file exists. So it's never going to execute this command. So this was the right idea of a make file, but in fact, when you say make, it's always doing this recipe right here. Okay, nothing wrong with that per se. It compiles your C programs, it gives you your executable. Here's the inefficiency of it, though. Suppose that I want to change the format of my print code. So I edit print.c, and now I say make. Well, it's going to recompile print.c, that's good, but it's also going to recompile pa2.c, init.c, search.c, delete, add, and freeall.c. Okay? Compilation of C code into binary is expensive, right? It's how long the thing is, but going from file.c into binary, that's an, okay, and if we just want to do that conversion into binary, we can say gcc-c file.c, and that gives us a file.o. It's the ones and zeros that correspond to our C code. Okay, but this is not executable by itself. So suppose we have a main.c, and we compile that, and it gives us a main.o. Well, this has the stuff that's going to be a main program inside main.o, but it makes a call to files somewhere, right? We have a function called file sitting in here. It's going to make a call to that. When we're compiling main.c, it doesn't know where this subroutine is going to be in memory. So it puts in a little blank line, and it says, I got to fill this in later when I know where this thing is in memory. So what we want to do is take our objects, main.o and file.o, and link them together into an executable. That linking process is really just kind of filling in those blanks. Now it says, okay, file.o, it's got a subroutine in it. I'm going to store that right here in memory. And then it looks at main.o and it says, oh, main wants to call that subroutine. Okay, I should call this location in memory. And it fills in those bits to specify where that subroutine is called, right? So this is linking, and that's pretty inexpensive, right? It's not taking a million lines of C code and parsing it out and turning it into binary. It's just putting these objects together. So if we had done this make file differently, if we had linked the .o files together, right, this instruction itself is pretty inexpensive. And now if you change print.c, well, you got to recompile print.c. There's no way around that. You change the C code, you got to recompile. But after recompiling that one relatively small piece of code, now you just say link all your objects together. And it doesn't recompile add and search and delete and all those other things. So a better version of this might have been to do something like this. Right, so now PA2 depends on these objects, and if you have the objects, they get linked together to make the executable. And then we have recipes for making each of the objects. So pa2.o, init.o, and so on, and they come from the C files. And now if I say make, yeah, I knew I messed something up.
So those only have G switches, not C switch? I don't know if that's
Yeah, I munched something else, didn't I? COO. There we go. And All right, so if all we have are our source files and we say make, it builds everything together. And if we say make again, it says PA2 is up to date. So it's a more efficient kind of, like I say, the ones that you turned in for PA2, if they were doing something like, compiling all of C or something, I'm okay with that. But be thinking about make files and see if you can make them more efficient, okay? Because this will help with bigger projects. And it's a skill you want when you move on from Clark. Here's a better kind of make file. So here I've got a symbol defined in the beginning. So I set up this symbol named CC, and I say I want CC to be a symbol for GCC. Okay, it's like an alias. And now when I want to use the value of that symbol, I can use this very particular syntax, $, parentheses, CC. So here it's actually going to interpret this as GCC-O. Down here it would interpret this as GCC dash, and so on and so. Debugging, change that one line, and now whenever I say CC, it means GCC-G, and that'll automatically give me my debugging. And if I wanted to use some different compiler, if I wanted, C99 or something like that, I can change my symbol up there. And you can use these symbols anywhere that you want, right? Yeah. To store that stuff. Oh. It's not my make file though. Okay, so there's our make file. So if we say make, everything's up to date. If we say make clean, it does that, remove everything. If I say make clean again, it'll give me an error because it can't remove those files because they don't exist. That's the thing I wanted to go through before getting into trees is using GDB. So this particular set of code, when I ran it, it was doing some quirk what was going on and what the problem was. And so I wrote to the student and said, hey, first of all, I gave them the feedback on what was going on. And I said, hey, is it okay if I use your code in class to demonstrate GDB? And they're like, yeah, that's fine. So I'm going to do that here. This was their make file. And this is what it looked like when I untarred it. So I said make, and it compiled up PA2, and I did valgrind PA2. All right, so I insert a 10, and I print the list, and it's got a 10 in it. That's great. I insert a 20, I delete the 10, and I get a warning from valgrind. Okay, I didn't take off for warnings per se, but your warnings usually cause me to look at certain pieces of your code more closely, and if I found things in there that were actual problems, then I might have taken off points. And let me show you the most common problem that I saw. Yeah, I figured I'm getting ready to go to the board. All right, well, let me show you the most common. Oh, not good. So this is what I found in code sometimes. So this is at the end of a delete routine. So you free the temporary node, and then you take the previous node, and you get it to skip over the node you just deleted by saying previous next equals temp next. Right? This is not correct code. The problem with this is once you free temp, you are not allowed. And then we delete the 10, and we get this warning from valgrind. And it's telling me that something went wrong inside delete, which was called from main. It's giving me the program counter address, which doesn't really help me. I'd rather see a line number, but valgrind doesn't do that for us. But I know somewhere in delete there's something happening, and it's saying uninitialized value of size 8. That may or may not help us. Okay, so let's GDB this. And when I exit, I get all kinds of backtalk. But I'm just going to look at the first issue that came up. So go back into our make file. I want to add debugging switches, right? And I didn't use a symbol in this. It was just GCC. So how do we do that? Well, global substitution is usually your friend, except when it's not. So I'll just replace every instance of GCC with GCC-G, and now it looks like my make file will turn on debugging. So I'll say make, and PA2 is already up to date, so I'm going to remove PA2, bless you, and say make. Okay, that should have debugging included. So GDB PA2. All right, we think the problem's inside delete. So I'm going to put a breakpoint at delete. I'm just going to say break delete. See what's going on. So I hit my breakpoint, and it says I'm at line 10. I'm about to give a value to the variable temp.